Okay, so this problem is another lens problem. So we have a certain lens focuses light from an object 2.7 meters away as an image 48.3 centimeters on the other side of the lens. What type of lens is it, and what is its focal length? And is the image real or virtual? So I just wanted to show you, we've done a number of ray tracing problems, and I just wanted to show you like a cheat sheet about ray tracing to give you kind of a feel for what's going on. So in this example, notice my object is 2.7 meters away from the lens, and my image is 48 centimeters. So the object distance is a lot bigger than my image distance. So if I were to just draw this, right, if this is my positive lens, it's like I have an object like way back here, and then I have like an image over here. And I'm going to say that my image is inverted. So I'm going to say it's like something that looks like that. That would be my guess. And that's because I know a little bit about how the object and image distance relates to focal length. So I just wanted to show you this cheat sheet, right? And this cheat sheet shows you, okay, what happens. This top one shows you like what happens when, oops, what happens when you have rays from infinity. The light focuses at the focal point. This one shows you when I have a ray or an object so this is my focal point here, and this is my 2 times my focal point. So if my object is here, you can see I have a smaller image here. In this example, we have the object right at twice the focal length, and so we have an image at twice the focal point. And notice they're the same. The heights are the same. On this one, we have an object inside two times the focal point, so between twice the focal length and the focal length. And we notice that our object image is inverted and larger than our object. Here we have an object inside the focal point, and so you can see I have diverging rays over here. And actually, this is right at the focal point, so I have rays that are leaving parallel to each other, so they'll never converge. So this means I'm going to have an image at infinity. And here I have an object that is inside the focal point, and I end up with a virtual image. So if I think about our problem, right, we have an object that's really far away, and we have an image that's really close to the lens. So I'm going to assume we have this situation. So I think my image is going to be real. So it's going to be a real image, right? This is a virtual image where I have to trace rays from image space back into object space, and that would be a real or a virtual image, where this is definitely a real image. And let's see if we can do some calculations here. Go back. Okay, so let's use the calculations that we know. So what type of lens is it? What is its focal length? So I can use the thin lens equation, which is 1 over d0 plus 1 over di is equal to 1 over f. And I can plug in, so that's equal to, plug in d0, I have 1 over 2.75 plus 1 over 0.48. I'm converting the centimeters to meters. And when I work that out, I get 0.364 for this fraction, plus 2.07 for the second fraction. So I get 1 over d0, or sorry, 1 over f is equal to 2.43. And that means that f then is equal to 0.41. So 0.41 meters, or we can say it's equal to 41 centimeters. So 41 centimeters. So our focal length is inside here. So you can see I'm going to have a focal length that's like there on my image. It's in between the lens and my image. And like I said, it's definitely a real image. And I have a convex lens. And how do I know that? Well, convex lens causes my rays to converge, right? So that means it's coming in here and it's going to be going like that. A diverging lens, my rays, when it hit the surface, would diverge.